All right. For some of us, traditional division is not our favorite. So I wanted to show you one other way that is helpful when thinking about division, and it's called partial quotients. Now, the root word in partial is part, okay? And that's important because whereas traditional division, we have to find the exact right number of groups the first time, or we've made a mistake for the rest of the process, partial quotient, allows us to take just the parts that we know and know well and get down to the same answer. Okay. So in my classroom, I often call this hangman division because the way it's set up to me looks like the game Hangman. Google calls it the big seven or partial quotients. All of those would be synonymous as we are talking about this. One of my favorite strategies is to simply turn my paper so that the blue lines are now helping me keep track of my place value. So it looks like this, where each place value now has a home and my numbers won't run together. Because division has several steps, oftentimes if we try to cram our numbers together, then we can make silly mistakes just by misreading a number. So this is just a way to combat that. You can use this strategy with multiplication, addition, subtraction, especially adding and subtracting decimals. Anyway, continuing on. So if we do 76 divided by 3, okay, this is where it looks like the game Hangman or a big 7. Okay, partial quotients, I'm going to be thinking, this is kind of my answer bubble out here, and this is where I'm going to be showing that repeated subtraction. Okay, the first thing I want to do in partial quotients, especially if it's a number that I know and know well, I like to do like a quick brainstorm about everything I know about that divisor. Because multiplication is the opposite of division, that's what I'm going to think about. So I know that 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. I love showing my work ahead of time. So then once I get into my actual work, then I can simply focus on the work and not the multiplication. Okay, now if maybe you don't know all of your threes, that's fine. Write down the ones that you know. This is extremely helpful as we get to the larger numbers because of the multiples of 10. Because if I know that 3 times 1 is 3, 3 times 10 is 30. And 3 times 2 is 6, so therefore 3 times 20 is 60. See how the 2 and the 2 are the same? The 6 and the 6 are the same. We just added that 0. So now I not only know my multiplication facts 3 times 1 through 8, but I know 3 times 10, 20, 30, 40, 50, 60, 70, and 80. And continuing on in the hundreds and things like that. So I want to jump into my partial quotients. This is where I'm going to be doing that repeated subtraction. This is where I'm keeping track of the number of groups that I've collected. Okay, so I'm going to start with 10 groups. Okay, and because 10 groups of 3 is 30. This is that repeated subtraction step. So 6 minus 0 is 6, and 7 minus 3 is 4. I see that I can take another group of 10 here, and now I have 16. Now I can go to my bank over here and see which one is closest without going over, and I notice that 15 is closest without going over. So how many groups of 3 is that? It's 5 groups of 3, and 5 times 3 is 15. And I have 1 as my remainder. Okay, now partial quotients is great. Back to that root word of part, because I started with a group of 10 and then another group of 10. But maybe you made the connection and you decided to take a group of 20 out the first time. That's okay. Our parts, the parts that we take out each time, don't have to be identical to each other, but we'll still get to the same quotient in the end. Okay, I know I can stop with partial quotients when what's inside is less than my divisor. So since 1 is less than 3, I know that I can stop. What's left inside is now my remainder. Everything on the outside, now I simply add up and I can find my quotient. One quick thing to note is because I turned my paper, I was able to keep my ones and my tens placed separate. But if you were to have accidentally written it like this, which is fine, you just need to remember that this is not 50 and that your answer is not 70, but instead this goes in the ones place because 10 or 0 plus 0 plus 5 and 1 plus 1 is 2. So my quotient is 25. My remainder is 1. Okay, let's do another problem together. I challenge you to pause the video right here and try this one if you're wanting to try partial quotients. So I'm moving on. If you want to do it with me, that's great. Or you can pause the video right here. All right, my brain storm is 8 times 1. Okay, and maybe that's all that I'm confident with on my 8s, which is just fine. We can use what we already know to help us master something we are learning today. And I'm going to stop there. Okay, so this is my brainstorm. I think all work is good work. And if I can do it ahead of time to help myself later, even better. So I draw my hangman sign. I'm splitting 109 things into 8 equal groups. So I'm going to start with 5 groups and subtract 40. It becomes 10 minus 4 is 6. You could regroup if you wanted to. I can take another group of 5. And now I have 29 left. So I'm going to go back to my work and see that, 24 is close. So I can take 3 groups and subtract my repeated subtraction. 9 minus 4 is 5. Okay, and I know I can stop y because the number inside is less than my divisor. Okay, and I'm going to now add up the groups that I made on the side. 5 plus 5 is 10, plus 3 is 13. So my answer is 13, remainder 5. All right, last one that we're going to do together. We're going to increase the difficulty and go to those double-digit divisors. For me, partial quotients is the best when I'm doing double-digit divisors because I don't always know my 15s or my 26s or whatever that divisor may be. So this allows me to use what I do know to take the groups. Okay, so for my brain dump, I know that 15 times 1 is 15. Therefore, I know that 15 times 10 is 150, and 15 times 100 would be 1,500. I know 15 times 2 is 30, which means, and I may not know 15 times 3, but I can double this one. 15 times 4 is 60. And I'm actually going to stop there. Those are the only numbers that I know confidently right now about my 15s without having to do a lot of extra multiplication. So we're going to see how far that mentality gets us. Okay, that I've done the ones I know confidently. And I make my big 7 or my hangman, whichever one you want to think about. Okay, in my brainstorm, I see that 30 is 15 times 2. Now, if I only take two groups out, we could do that, but it's going to take us a very long time. But I can find some related facts that I know 15 times 20, 15 times 200. Okay, 15 times 20 is 300. So 15 times 200 would be 3,000. And this is the one that's going to help me. So I'm going to start, I've kind of worked into my problem here, sorry. 200 groups of 15 gives me 3,000 that I can subtract. So 9, 7, 0, and 4 minus 3 is 1. Okay? Then I'm going to come, I know that would be 150 and then 1,500, and that's too much. So I'm going to find a related fact that 15 times 40 is 600. So I'm going to take a group of 40. Okay, and then a group of 20. So I'm just using the ones that I'm confident in to help me get down to my answer on my quotient. I'm going to do a group of 10. And now I'm to 29. Okay, I'm going to take one group of 15, and I see that I have 14 left over, which is less than my original 15, and so I stop. If you'll notice, my strategy is to always circle the remainder, so I circle when I know to stop. That's just something I like to do just for my own uh, documentation. It's a strategy that I use. It's not a required strategy. Then I can add up my total number of groups of 0, 0, 0, 0, and 1. 0 plus 4 plus 2 is 6 plus 1 is 7, and only 1 left. So my quotient is 271 groups with a remainder of 14. Okay, this is partial quotients. Again, it's nice because you don't have to get all of the exact right groups the first time. You can just take small pieces as you go. The more you do this, the bigger the chunks you'll recognize you can take. But you can start with as small or as large of a chunk as you can without going over what is in your dividend. This is partial quotients.